Okay, hopefully you've done your pre-lab and you know now a little bit about equilibrium. And what we're going to do is we're going to use your knowledge of equilibrium to investigate a system that's shown here. This is a balanced chemical equation between cobalt hexahydrate and cobalt chloride. And what we're going to do is one of the sides of this reaction is pink and one of the sides is blue. First thing we're going to do is we are going to look at two experiments that should help you determine, is this blue or pink, or is this blue or pink, because these are colorless. Then after that, this reaction is endothermic or exothermic. You're going to figure out which. You're going to determine where the heat lies. Is it with the reactants or is it with the products? So let me show you what we have here. Now what I did is I made this cobalt solution. Remember I just said one side is going to be blue and one side is going to be pink. I kind of made the solution right in the middle. This is violet. So basically I'm sitting in the middle, and as I perturb the equilibrium, we're going to see it go to either the blue side or the pink side. Okay? So for your first answer, it says, what is the color of the solution in the test tubes? It's violet. Okay, the first thing it says is add a few drops of concentrated hydrochloric acid. So I'm going to take one of the tubes and I'm going to do this kind of off camera. Some of the things I'll do on camera, and I'm going to put some hydrochloric acid in there. This is concentrated. So concentrated is about 12 molar. So let's get our control. This one here is the control, the violet, and look what's happened. When I added concentrated hydrochloric acid, I now have a blue color. This is my control. This is the control with HCl, or hydrochloric acid, added to the solution. So when I added a few drops, the new color formed is blue. So what you're going to do is you're going to answer questions based on what you just saw. The rest you can do. You're going to write a balanced chemical equation of the interaction between HCl and water. What happens when we add the HCl to the aqueous solution? You're going to determine whether it shifts left or shifts right, and go from there. Okay, the next thing we're going to do is we're going to take one of, and I think I can do this one under the camera. Pretty easy. So I'm going to take, it says, add a few drops of silver nitrate to the solution. Okay, so I'm going to take one of these. Remember, it's a violet color, and I'm going to add some silver nitrate. All right, two things happened here, didn't it? I've got a color change, and I also have a precipitate when I add it. Here's my control, here's my violet solution, and when I added silver nitrate, I got this precipitate. So what we have here then is, what is the new color formed? Is pink. And when silver nitrate was added to the solution, I formed a precipitate. Precipitate. Okay? So, from those two experiments, you should be able to deduce which one of these is blue and which one is pink. And that will be determined. And then that way, you'll be able to determine which side is blue and which side is pink. Okay, next thing we're going to do is heat. So we're going to look at, oh, sorry, I missed one. So no, let me go back. This is the coolest one too. I don't want to forget this. The next thing we're going to do, and sorry, this bled through the paper, but I'm going to press on. Okay, I've got this equilibrium. The next thing I'm going to do is I'm going to add water to my equilibrium. All right? And so I'm going to do that next. I'm going to take this one, okay, and I'm going to add water to it. Look at that. All right. So I added water to the equilibrium. I have pink. So what is the new color? Pink. This should also help verify what side of the reaction you think is pink and what side of the reaction is blue. This will also help you do that. But it's also a discussion in what happens with dilution. So you're going to go through a series of calculations down here where you're going to enter the species as variables A, B, and C. And basically what I did is I added about 2 times. So what did I do? I cut my concentrations in half, each one. So rewrite your equilibrium expression showing that A, B, that the species were all cut in half by the dilution of the water. Okay, now we're on to heat. So we're going to go to the last page right before your, here we go, right before your post lab. Okay, so what I've got here is I've got 2 beakers, one's hot and one's cold. Okay, so I'm going to take 2 test tubes. Again, they both have a violet color, and I'm going to put one in ice and I'm going to put one in hot water. Now, to me, I think temperature tends to be the most problematic for students to figure out what happens with the color change and why. Now, if I look at this, look what's happening here. It looks to me like if I compare them, I am more on the blue side on the right and the pink side on the left. So I put those in there. And what this is going to do is once you've determined which side is blue, which side is pink, and I heat them up or cool them down, that should tell you how the reaction is shifting, just like we did with the Haber process. We did that. Remember, we had N2 plus H2 goes to ammonia, and we watched the reaction, temperature of the reaction decrease. All right, so let's look at that. Now, let's switch them. Let's verify, is that really true? So I'm going to go ahead and put them in. Remember, this is real pink color, and this one was real blue. The cooling one usually takes the longest amount of time to get to work. But let's look. So already I can see, look what's happened. The blue color that was once pink is now blue. So what that tells me is that when I heat this equilibrium, I shift blue, and when I cool it, I shift red. You can't really see that yet. I can see it. It's turning back to violet, and it will turn back to red. So let's see if we can. In fact, can you see? Let's look at the difference between them. This is the blue. That is now violet. So this one on the bottom went from the bright blue color that it had in the heat, and now it's transitioning through purple. And if I let it sit in the cold long enough, what we know is that if you cool it, it shifts pink. Okay? So that means what color formed when the temperature increases? Blue. And what color is formed when the temperature decreases? Pink. Okay, that information that I just gave you should be enough for you to finish the packet. So I want you to go through all the way to post lab. For you guys in KVA, you will do the lab, scan, and submit. Good luck.